Okay, for you guys, I decided to try to do a problem about discontinuity. So I'm going to look at 17.10a. In this function, they tell us that f of x is equal to 1 if x is bigger than 0, and they tell us that f of x is equal to 0 if x is less than or equal to 0. All right? And they ask us to show that it's discontinuous at x naught equals to 0. Now, if you think about the picture, this should be pretty clear. If we're going to draw a graph of this function, the function is apparently supposed to be equal to 1 if x is bigger than 0. So, if we call this 1, it's like saying we've got an open dot here, and a line going that way. I'm sorry, it's supposed to be a straight line. It's also supposed to be equal to 0 if x is less than or equal to 0. That would look something like this. We're going this direction. So the function pretty clearly makes a jump discontinuity at 0. So how are we going to prove such a fact? We're going to try to prove such a fact. We have to use the definition of continuity. So the definition of continuity, according to Ross, is that a function is continuous. Function f is continuous at x naught if for all sequences xn that converge to x naught, we have that f of xn converges to f of x naught. All right? So in order to show a function is not continuous, that means that we have to show that we do not satisfy this. So in other words, we have to find a sequence that satisfies the antecedent. In other words, xn goes towards x naught, but violates the consequent. Well, if we look back at our picture, there's going to be a bunch of sequences that would possibly work here. So since I know that f of 0 is equal to 0, because that falls into this condition, what I'm going to try to do is I'm going to try to find a sequence of x values, kind of like, let me use a different color here, red, that converge into 0. Because if I find a sequence that converges towards 0, that's positive, all of its outputs will always be equal to 1. It keeps bouncing up there to 1. So I can find a convergent sequence that I'll get something going towards 0 for the x's, but the f of x's will go towards 1 because it'll be constantly 1. And that would prove discontinuity. So, proof. Let xn equal 1 over n. Then xn obviously goes towards 0 because the limit as n goes towards infinity of 1 over n is 0. Notice, since 1 over n is bigger than 0, we have f of xn is equal to 1. Because in that definition of the function, every positive number gives you 1. Well, then, the limit as n goes towards infinity of f of xn would also be equal to 1, because f of xn is equal to 1 for every single one. Right? So, we have a sequence, xn equals 1 over n, such that the sequence goes towards 0, and we have the f of xn's, which go towards 1. This is a problem for continuity because f of 0 is equal to 0. Right? When you stick in 0, since 0 is less than or equal to x, or x is less than or equal to 0, we get an output of 0. So here we have a function that heads towards 0, but the f of x ends go towards 1, which is not 0. This establishes that f of x is not continuous at x equals 0, at x not equals 0. Interesting.